You get it. It says sinusoidals, not sinus yodels. Welcome to Math Think. Let's talk about sinusoidal functions, not sinus yodel functions. Welcome back, math thinkers, math fans out there. We're going to be talking about the graphs of sine and cosine. My goal is just to introduce to you the reason why the graphs of sine and cosine look the way that they do. In order to do that, we're going to have to revisit our understanding of the unit circle. Let me just go ahead and draw a quick little, nothing special circle here. There we go, perfect. So just to revisit for a second on the unit circle, when we graph it on the x and y plane, a few things to remember, that the radius is 1, and if we rotate around the circle, let me draw a quick little triangle here, we can think about the coordinates as creating a right triangle, with this side here being the x coordinate and this side being the y. The hypotenuse is always 1. Which is kind of special. If we have an angle of rotation here, then that means that the value of sine at that position is going to be equal to the opposite over the hypotenuse. If you remember your trig functions from geometry, sine is always referencing the ratio of the opposite side of a right triangle to the hypotenuse. So sine will always be the opposite side, which really is the y coordinate, over 1. So opposite over hypotenuse, opposite over hypotenuse, opposite side over hypotenuse, which is really just y, and cosine of that angle is equal to the adjacent side, which is really just the x coordinate over the hypotenuse. So the adjacent side over the hypotenuse to this angle, which is really just x. So this is really, really cool because now we know that the sine of an angle as you go around the unit circle is really just the height that you are as you go around the circle. And the cosine value is equal to the x coordinate. Really cool special things happen when we start to think about the graphs of sine and cosine. So now that we've revisited the idea that the y coordinate on a unit circle is the value of sine, let's take a look at how those values behave as we travel around the unit circle. In order to do that, I'm going to draw a quick little unit circle. Nothing special going on over here. Just really, free-handing unit circle. There we go, no big deal, just really easy. So we have our unit circle. I'm gonna do the first thing I always like to consider, especially when I'm thinking about the questions and graphs, the questions that we're gonna be dealing with. I'm gonna cut this circle in half and say that this right here is pi. We're gonna start here. This is a rotation of 0. Well, let's make a table. If I wanna look at how the values of sine behave as we travel around the circle, look at a table of values. And the table of values that I'll consider will look something like this. I'll have an x column as we travel around the circle. I'm going to evaluate sine of x as we travel around, and then the value of sine we're going to say is our y. So as I make this table of values, I'm going to be making a graph. This will be values of y, and this will be our x. So I'll kind of plot our points as I consider rotating around the circle. So the easiest point to consider, x is the amount of rotation around the circle. So let's say and think about what happens when x is 0. When x is 0, remember that sine is the value of the height as we go around the circle. Sine is the value of the y coordinate. So if we think about that for a second, if we're at 0, there is no height. So sine of 0 really is 0. Speaking of heights, do you hear that plane? We have a height of 0 if we rotate nothing around the circle. So I'm going to plot this point 0, 0. So when x was 0, when there was no rotation, we had no height. Okay, so 0, 0. Now let's go to the next easiest piece, and well, if halfway around the circle is pi, let's consider this. Halfway around the top half, so this is half of pi. So when we rotate half of pi around the circle, we're at a large height here. So when x is at a half of pi, the value of sine at half of pi, once again, is equal to the height. Sine is equal to the height as we go around the circle, and that is 1. So at pi over 2, I'm going to plot this point as just kind of over and up. At pi over 2, I'll say is right here, right, half of pi, we're at our highest point, which I'll say, so I'd have to go pi over 2 up. So at half of pi, the value of sine is 1. And we can keep rotating, so I'll rotate down to pi. So when x is pi, sine of pi is equal to the height. Remember, sine is the height as you go around. And notice that we came back down to a height of nothing. So sine of pi is also 0. So at pi, so if this is half of pi, double that and I'll get pi. So at pi, we get down to 0. So I'm plotting the values of sine as we go around the circle. So the y coordinate is the value of sine at x. And that kind of makes sense. We start 0, up, down. We can kind of keep rotating here. So I'll go by halves of pi. So if I do this again, this is 1 half, 2 halves, 3 halves of pi. So at 3 halves of pi, well, sine of 3 halves of pi, once again, is equal to the height. And now we are, you can think about it as below the x-axis. So now we're at a height of -1. So if this was 1, this is -1. So at 3 halves of pi, we're going to be at a height of -1. We're kind of plotting, and then we can go all the way around. So 1 half, 2 half, 3 half, 4 halves, or 2 pi. 2 pi kind of makes sense because it's 2 halves of the circle. And so sine of 2 pi, we get back home, right? If we go all the way around the circle, we get back to a height of 0. So here's 2 pi. So 2 pi, we get a height of 0. Cool. So what does all this mean? It means that we have a graph that starts at 0, goes up to 1, down to 0, down to -1, and back to 2. So I want you to watch the following animation of the graph of sine as we plot it like we're doing here. It's going to look a little bit different. So you're going to see a circle, and you're also going to see the graph as, so you'll see a point rotating around the circle, and then you're going to see another point kind of showing the height as you go around the circle, and then green corresponds to the height. So you'll see two things of green. So I'm going to go over here to my Desmos really quick, so make sure I'm doing this okay. Let's start with maybe pi over 2 first, so just to kind of show you what you're going to be seeing. So at pi over 2, notice here we have the top half of the circle, and then we have this coordinate half of pi and 1. So if I go to pi, this is kind of just plotting the circle as we rotate around and the height as we go around. And then we also said that at 3 halves of pi, it's down at -1, and we said that at 2 pi, it's back to 0. Okay. I'm going to play this in slow motion just so I can animate this. I just want you to watch very, very closely as to what is happening here. I believe it's on fairly slow speed. So just go ahead and watch this animation really quick. I find this really helpful in understanding where this graph is coming from. We'll play it in 3, 2, 1. So the heights are matching up. The purple point is plotted as an x and y coordinate, and the black point is just simply rotating around the unit circle. The purple point is plotting those sine values as we rotate around. Let's play that one more time. There's a cool shape that you might have noticed, or if you kind of consider, the values one more time. Notice how it's not like totally angled. It's not a very violent, when it goes like down to its lowest and then coming back up, it's not a very violent change. It's a very gradual change. And watch this, watch this, watch this. Okay, so I'll bring it back, and I'm actually going to have I'm going to plot the function as we go around. I'll slow it down a little bit. So here we go. Just go ahead and watch this animation for a second. So now it's not just plotting those 5 particular points, it's plotting a lot more points as we go around. And it's plotting the heights as we travel around this, the unit circle. And we get this beautiful, amazing curve. So when you look at graphs of sine, you're going to see this wave form. And this wave comes from the fact that we are traveling around the unit circle. And it turns out we can just keep going as well, right? We say that the domain of this function is infinite because that kind of makes sense. For a circle, we can just keep rotating. We get this amazing wave that forms from plotting the heights as we go around the unit circle. It's called a sinusoidal function. Okay, so now let's go over a little bit of vocabulary on these types of graphs. These are called sinusoidal functions. They all kind of have a wave shape. There's another one that we'll take a look at here in a second, but just to introduce some vocabulary. The first piece of vocabulary you should know is, well, in no particular order, I guess, if I were to make this wave of what you just saw, so I'm going to label maybe the first thing you should know is this thing called amplitude. And the amplitude is the height of either a maximum or a minimum, I guess the distance really, of the wave in relation to what's called the midline or the center line. So this line right here, which can move, in this case here it's just the x-axis, is called the midline. So the amplitude is always the distance of a highest or lowest from the midline. And then there's another idea which is called the period of the function. The period of the function is just how long it takes to make one full rotation. And on a unit circle, the amount of time it takes to make one full rotation is 2 pi. And so on a graph like this, really, this orange rotation is the distance that it takes for a full rotation. So this orange here is called the period of the function. In other words, once you go up, down, and back, notice how it's just going to repeat after that. So really when we graph, it's really important to understand and analyze one full rotation, one full period of the wave. If you understand how one full period of the wave is behaving, you know how pretty much the entire thing is going to behave after that. So amplitude, period, and midline are 3 vocabulary terms that you should be familiar with. So I know what you're thinking. What about cosine? What does that look like? What does that look like as we travel around the unit circle? Well, let's do some investigating here. Remember that cosine is not the value of y, but it's the value of x. So we'll keep that in mind and make our adjustment here accordingly. We'll start with these nice 4 points. So if we rotate a 0 amount around the circle, then we're going to be looking at cosine of 0. Well, cosine is the x-coordinate. So if we've rotated 0, this is the coordinate 1, 0. So our x-coordinate, you'd have to go out a distance 1. So cosine doesn't look at the height, it looks at the horizontal distance as we travel around the unit circle. So the horizontal distance that we start. In other words, cosine starts at its furthest away from the center. So cosine of 0 is 1. So I would plot the point 0, 1. So cosine actually starts at its most stretched out. And then as you travel around, this distance decreases, right? So like if I'm all the way out here versus here, my distance is now a lot smaller. And if you get 2 pi over 2, cosine of half of pi is right here. And notice that there isn't a horizontal distance right here. This is the coordinate 0, 1. So the cosine of half of pi is 0. So if I were to plot this very similar to like we did last time, here's pi over 2. And so cosine starts at its furthest horizontal out, and then that horizontal distance becomes smaller. So the next point, or the next important point on it is pi over 2, 0. And then it keeps going actually backwards now. So if we rotate, we get further back here. So like at this point, we have to go to the left. Eventually you get to pi. And cosine of pi is at its furthest to the left. And if it's to the left, that is -1. So if we keep going, this is 0, half of pi. Here's a full pi. And at a full pi cosine, the horizontal distance around the circle at pi is -1. And if we keep going to 3/2 of pi, cosine of 3/2 of pi, this horizontal distance is large, then it becomes small, then it becomes large, then it becomes small again because we go around, and now we're at this point here, which has the coordinate of -1, 0, -1. And so you don't have to go out any distance, you just don't go out 0 and then down 1. So the cosine, the horizontal distance at 3 pi over 2 is 0. 3/2 of pi gets back to 0, and then eventually make a full rotation to 2 pi. So cosine of 2 pi gets back to where we were. And so the horizontal distance at 2 pi gets us back to 1, which is kind of interesting. That means that cosine looks very, 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 very similar to sine, except it's shifted a little bit. Cosine starts at a high point and then goes down, and then changes its horizontal distance, or it changes direction at pi because now it's coming back into the origin, and we get these nice curves. Awesome. So cosine looks very similar to sine. This is the graph of cosine. You'll notice it's the same shape. It's just been transformed a little bit. The same amplitude, midline, period. So the period is 2 pi. Once again, you'll notice that if we go from peak to peak, right? So it starts up, then down, then back up. The period is still the same. It's 2 pi. Amplitude of this is 1. For the unit circle, we'll take a look at some other examples of where the amplitude changes, the period changes. Right now, the goal of this video was to show you why the graphs look the way they do. And if we compared sine of x on the same graph, it would look something like this. Sine starts at 0, goes up to 1, down to 0, down to 1, and then back to 0. So sine looks a little bit different. Once again, it's pretty much the same shape, but it's shifted a little bit. And it is shifted. It's a really cool looking shape there. I love that shape. So this is sine of x. The purple is cosine of x. But yeah, so they look very, very similar. So all the same vocabulary terms. Just remember that cosine starts at its furthest out. So cosine is the horizontal distance, sine is the height. In hindsight, I wish I would have remembered that sine was the height. Is a friendly way that I remember. I think that's all I wanted to get through in this video. So this is where the shape of sine and cosine come into play. In the next few videos, we'll look at how to transform them and the logic behind why some of the transformations are the way they are. Thanks for watching. Make sure you subscribe. We're getting to 200 subscribers, getting that wasabi challenge coming in. Really spicy, maybe a mixture of trivia with some spice, but a different type of spice. This spice doesn't linger as much, but it is very potent. Anywho, have a great rest of your day. This has been Math Think. Thanks for watching. Bye-bye.
Well, now I'm gonna teach you how to yodel just like me. It's easy when you're singing to go yodel-o-dee. First you take a deep breath and it's KO 1, 2, 3. Then you'll hear a yodel if you listen close to me. Yeah, this is how to yodel, yodel-o-dee.